జరగాలి అంటే చేతికి విడపు ఇవ్వాలి.
Welcome to the dynamic learning hub of ExcelR at Andheri East. A prime spot conveniently located at just a 5-minute walk from LIC Andheri Metro. In our journey of over a decade, we have proudly trained over 2 lakh students. We have also been recognized by Deloitte, Silicon India, and other accreditation bodies. Experience learning like never before in our spacious and comfortable classrooms. With high-definition projectors and state-of-the-art acoustics in place, we ensure effective learning even to the farthest point in the room. The hybrid mode is a game changer as you can enjoy the benefits of a live classroom from the comfort of your home. Even if you happen to miss any classroom session, you can still attend the same session with the same trainer at the same time at your convenience, maintaining consistency in your learning progress. Want to get started? Join us for a demo or career chat over a cup of coffee at our Andheri branch. ExcelR. We don't just train, we build careers.
Yes. So the collaboration with ExcelR was an excellent one. We conducted a Power BI workshop with Advanced Excel over a span of 3 days. The workshop was almost 12 hours long in total. Mr. Karthik, who was an amazing trainer, helped the students understand the concepts deeply. I am sure that the students will be able to apply these concepts in their careers as well as their daily lives.
The trainer, Mr. Karthik, was an excellent person where he explained in a very detailed manner on how great insights using very complex data sets.
So it was a machine learning workshop. We learned a lot from the course and a great experience attending the workshop.
The trainer was very helpful. He had a hands-on approach with his teaching and it was fabulous.
This was a great experience for me. So I would absolutely love it if ExcelR and its team would come again to our campus and conduct more events like this.
It was a great course and it started from basics and
Good evening, all. I hope I'm audible to everyone. Okay, we'll start the session. Adil sir, is I'm audible?
Yeah. Good evening.
Yeah, good evening, sir. You can take over the class.
Okay, fine. Thank you. Yeah, good evening, everyone. Hope I am audible. Yeah. Am I audible? Do confirm. Okay, thank you. Good evening, everyone. Hope you all are doing great. Yes. Okay, may I know what we discussed yesterday? Quickly, within 2-3 minutes, if you have any queries. Can you revise within 1-2 minutes, just the topic names? Yeah, good evening. Okay, so yesterday what we discussed, it was about complexities, right? Time complexity, space complexity, then asymptotic notations. After that, it was actually the master form, how we follow the recurrence relations, right? If you remember, we discussed yesterday recurrence relation, a relation in which nth term is defined in terms of its previous terms. So then how we solve those recurrence relations? With the help, there are so many methods. You can have iterative method, you can have substitution method, you can have this master form. Then after that, what we did, we explained this master form or master method. Then after that, we discuss all the three cases of master form, right? If a recurrence relation is of the form of T of n is equivalent to ATN by B plus F of n, then we discussed, then we explained all the things in it. What's A, what's B, what's n by B, etc., etc., everything. Then we discussed the three cases. And most importantly, I give you a crux of that master form. If you remember, I told you whenever you are getting a recurrence relation of this form and you have to find the complexity of that, always go with, you know what, f of n and n raised power log a to the base b, right? Always try to find these two things, n raised power log a to the base b and f of n. Then compare the values, right? Whichever value is bigger, that is the complexity. If you remember the case of that merge sort, 2tn by 2 plus n. Here is 2, b is 2 and f of n is n. So n raised power log a to the base 2, it was n and that was also n. So neither f of n is greater than n raised power log a to the base b, nor it is lesser. So at that case, both f of n and n raised power log a to the base b was equal. So for that, what we are doing? We are just simply multiplying either of the function by log n. So that's why the complexity of merge sort was coming out to be n log n, right? Similarly, when the function is greater, the complexity is the function itself. When n raised power log a to the base b is bigger at that time, then n raised power log a to the base b is the complexity. So these were the three cases, right, that we discussed. After that, we discussed something about, I guess, Tower of Hanoi, right? And I told you we have got 3 towers or 3 pegs, and we have got some discs, and they are in some order, like in an order on one peg. And our job is to move all these discs from one tower to another tower using the tower third. But there, I told you there are two conditions for it. One condition is that you can move only one disc at a time, and second condition is that no bigger disk can be placed over the smaller disk. So these are the two conditions. So based on that, we discussed it, how to solve it. And one more thing is that I have given you the recurrence relation for that Tower of Hanoi. If you remember, it was Hn is equivalent to twice h of n minus 1 plus 1. And I told you why this 2h n minus 1 plus 1, how it is coming. I have given the explanation and I have told you by example how it is coming. Then I told you how to solve this recurrence relation. It is with the help of iterative method. And the solution for this recurrence relation, or I can say the recurrence relation of the Tower of Hanoi, it was coming out to be 2 raised to the power n minus 1, right? So that's why we were just saying, if you have got 5 disks, what could be the number of possible moves in order to move the disks from one tower to another tower using tower third. So it was simply 2 raised to the power 5 minus 1, means 32 minus 1, that is 31. Means you will have to follow 31 steps in order to move the disks from tower A to tower B using tower C. When you have got 5 disks. Similarly, if you have got more number of disks, the number is increasing. And I have shown you by that demonstration how actually the disks are moving. Right? Then we discussed something about linear search, like master method, etc. etc. So that was till yesterday. And today, and after that, we gave some brief introduction of Java as well. Right? As I told you that this actually Java, whenever we are executing the Java program, it is actually a two-step process, isn't it? Right? We have first a Java program, the source file. We are converting that source file with the help of compiler into the bytecode. Right? Then we give that bytecode to our interpreter, and that is converting that bytecode into the what? Into machine readable code, or I can say the machine language. And it is simple. This is done by this source code to bytecode is done by compiler, and bytecode to program code, this machine code is done by the interpreter, like this. So it is actually a two-step process. Someone also asked this question yesterday as well. Why there are two things? Because it is actually a two-step process, and here we require JVM, Java Virtual Machine, we call that. Then we use some concepts of OOPS. We'll be explaining all these concepts briefly, not in detail. Briefly, we'll be explaining them today. Then we'll go with the data structures. Yeah, I guess we discussed it yesterday as well. What is an object? Simply an instance of a class is known as object. These are actually the basic runtime entities in an object-oriented system. Whenever you have got any kind of OOP system, so the objects are the basic runtime entities, right? And these objects, they are real-world objects. Yesterday, like I told you, it can be a car, it can be a person, it can be book, it can be table, etc., etc. So they have got some behavior and they have got some state. For example, you can have chair, you can have pen, table, etc., etc. Right? And these objects, they can be either logical or physical, right? Yeah, then we have got a class. See, yesterday also we discussed it. Class is actually a blueprint of a or prototype from which objects are created. Like for example, you are all students. You have got names, student 1, student 2, or I can say roll number 1, roll number 2, roll number 3, either by your name. So I will be creating a class, right? With the name, like suppose student, and all of you, student 1, 2, 3, 4, whatever roll numbers you have got or whatever names you have got, you can become the objects of this class. So this class is actually a prototype, right? So it is actually a blueprint from which the objects are created, and I will be creating the objects from this class. I hope it is clear. See, you are all students. I will treat you as objects. Roll number 1, roll number 2, roll number 3, etc., etc. And I will be having a blueprint or a prototype. I will call that as a student. And you all students will be belonging to this class that I have created, the student. So it will become a class. Or I can say this student is containing what? It is actually a collection of all the students whosoever is are present in the class, or whosoever have been put into this class. So actually it is a collection of objects. Whatever I have created, whatever I have put in this class. So it is actually a collection, or I can say blueprint or a prototype. And you know, it is a logical entity. If you see, like suppose student, myself, you, we are physically existing. So object, as I told you, it can be physical or it can be logical. But this class, it is a logical entity. Means it don't have any physical existence as such, but it is containing the physical object. Are you getting it or not? Whenever I am creating a student class, so this student class is containing some objects, and those objects can be either physical or virtual, or I can say logical. And it is most of the time the class is actually a group, as I already told. It's a collection of objects, and these objects are similar entities. So they are a group of similar entities. For example, you can have if a class is expensive cars, then objects like Mercedes, BMW, Toyota, etc., etc., can be the objects of this class expensive car. Similarly, its properties can be the price, the model, the speed, etc., etc. And methods. Methods can be driving, reverse, braking, etc., etc. So these are some of the properties, or I can say methods, and these objects to the class expensive car. So this is actually the basic definition of class. See here, you can have a student class, and these are the objects: student 1, student 2. So these are the properties of this class: name, grade, get name. These are the methods, right? That's it. Similarly, if we check here, this is the name of this object, object 1, student 1. This is the grade, and these are the methods of this object, and these are also the methods and variables of this object. And I have created how many instances of this class student? These are two instances. Similarly, if you are 100 in the class, 100 objects in the class student, I will say that I have created 100 instances of that class. Right? It is simple. So I hope it is clear. So we can say that these classes and objects, they are the main two aspects of object-oriented programming, because all object-oriented programming, they revolve around this object and class. So I can say that there are two main aspects of OOPS. And if we see, we have already told you that a class is a template of objects and an object is an instance of the class. Right? Means in the class, I am creating a collection of what? Collection of objects. And what is this object actually? An object is actually one instance within the class, or I can say one object of that class. One, I can say this, one element of that class. So that's why I am saying that object is an instance of the class. So that's why I'm saying class is template and object is an instance. Simply, your class, student, it is a template of what? Of all the students, whatever are, whosoever are present in the class. And what is a student? Student is a part of this class, part of the class student. So I'm saying the student 1 is an instance of the class, and class itself is a template of all the students. Right? So whenever the individual objects are created, they inherit all the variables. And see, we have seen that this student, this class, it is actually containing some variables and methods. Right? Like suppose here, or you can consider yourself. If you have got name, you have got some, I can say, like suppose age, or I can say you have got some grades in your subjects, etc. So these are some variables, whatever I require later on in the program related to the problem. So we have got some methods as well, means dynamically they are changing, dynamic behavior of the object. So we call them as methods. So whenever some individual objects are created, they inherit all the variables and the methods from the class. For example, if you have created this object, apple, mango, and orange, right? Whatever would be the variables of this class fruit and whatever would be the methods of this class fruit, they will be inherited to these objects. Like for example, see here, you have got variable, you have got methods of this class student. Now I have a student 1, I am creating this. So this student 1 will inherit these variables and methods. Similarly, student 1, 2 will inherit these variables and methods. And if I create a new instance of the class student 3, so that will inherit these variables and methods. So that is what I am saying. Inherit, I will tell you what inheritance is, I guess today itself, because we have to only give the brief this is the concept of these OOPS concepts. So simply saying, whenever we are creating a new object, that object is inheriting all the variables and methods from the class in which we are creating it. Yes. Now there are some OOPS concepts. You might have heard about it. Data abstraction. May I know what is data abstraction? Can anyone? In order to engage you, can anyone write a definition of? Otherwise, it is a like kind of this theoretical class. So that is why I just want you to type your answers. Inheritance. Waiting for your answers. 20 seconds. I will give you. Data abstraction. Sorry. What is data abstraction? Yeah, great. Hiding that it can show only useful data and hiding internal details. Good. Okay, great. See, actually this abstraction in OOPS, or I can say in Java, it is a fundamental OOPS concept. If I will go to Java, so I can say abstraction in Java is a fundamental OOP concept. And it not most of the times, it always focuses on hiding the complex implementation details. And it will, I can say, like, show only the essential features of an object. Means whatever are the complex features, it will hide them. And whatever are the essential features, it will show them. So what happens with it by hiding the complex features and showing the essential features? So it is simply helping us in programming, reducing the programming complexity. Because with the help of Java abstraction, it helps in reducing programming complexity. And at the same time, it will provide a clear separation between the abstract properties and the implementation details. Right? So that's why I'm saying that we are saying that it is hiding the internal details and showing functionality. That's called as abstraction. Means hiding the complex details and showing the essential features. For example, you can say like phone call. We don't know the internal, how actually it is happening, but we are talking on the phone. It is a phone call, so we are actually getting the fruit of it. I can say like essential feature. Okay. Yeah. So classes use the concept of abstraction, and they are known as means whenever we are using the concept of abstraction, we will be using abstract data type. See, can anyone tell me what is the purpose of this abstraction now? If we see, it has got some purpose. That is why we are using abstraction. The very basic thing is simplification. That I already told you. Because this abstraction, it is allowing these developers to work with the complex system, and it will simplify the interaction with them. With the help of this abstraction, it is actually simplifying the interaction within the complex system. And another thing is code reusability. Like it is a purpose of inheritance as well, this code reusability. Because by defining, I can say these are common interfaces, abstraction promotes code reusability across multiple implementation. And then the very important purpose of abstraction is the security, enhanced security, because it is hiding what? It is hiding the internal implementation details. Like I told you in calls, phone calls, we're actually getting the what is happening inside that we are not knowing. So it is actually what? It is actually hiding the internal implementation details. Thus, it is protecting the code that we are writing from unauthorized access, and no one will be able to modify that. It is not allowing the modifications to outsiders. Right? Then I am just saying, whenever we are using data abstraction, there is a data type. We call that as abstract data type. Right? And these classes are defined as a list of attribute abstract such as these size, weight, cost, and methods that operate on this. The technique of creating new data types that are well suited to an application to be data abstraction that I told you. And in Java, we use abstract class and interface to achieve abstraction. Now, what is abstract class? Yes, what is abstract class? See, whenever we are creating a class in Java, we are I can say we are instantiating that class. But this abstract class is a class that we cannot instantiate, that cannot be instantiated on its own. And it is containing the abstract methods. Means these abstract methods are actually without body. And they are implemented by it is subclass. I will show you. Let us take the example. I guess I have written the example over here. Yeah. See here. Hope it is visible. I have created an abstract class animal. As I already told you, these abstract methods, they don't have any body. See here. I have created a method animal sound. Right? Then a regular method, it is sleep, print system.out.println this. Then I have created a subclass, and I have inherited this subclass from this animal, the class that I have created, this abstract class animal, and now I am creating a subclass, right? Because I am inheriting this subclass from animal. Then I am creating a method again, this animal sound, the cat says meow meow. Class main. See, if I will run it, let us check. I guess I have. Let me share. Okay, I will do one thing. I will not run it in this VS Code right now because it will take much time. I will be simply running it on online browser. Online this na compiler. Let me check. Can I share? Where is the browser? Compiler. Let me share this. Okay, hope this screen is visible. Yeah, this is the online Java compiler. Let me run this code. I have somewhere written this. Abstraction. Let us check what will happen. Hope it is visible. Please confirm, is my screen visible? Yeah, I can use notepad, then I have to see. Nowadays, you can run program several times. So I will be using the online compiler because it is easy for me to write. Otherwise, I have to save files, this, that. In order to save time, I will be simply running it on the online compiler, right? Okay, fine. See, first let us check this. We have an abstract class that I already told you. Then I have this method, and abstract method is different from the normal method because abstraction method don't have any kind of a body. They does not have body. Then we have a regular method, this public void sleep, then stem.out, or simply a message would be printed. Then I will be inheriting, I will be creating a subclass that will inherit its character, its features from this class, from the animal class. Simply what I will be typing, I will be creating a class animal. Then I will be creating a method for this animal sound like over here, and simply I will be printing this. So it will be actually abstracting it. Let us check by running it. See, the cat says meow meow. See here. And after that, I am printing this triple Z message. So this is how actually this abstract class is working, or how data, what data abstraction is. Right? Here, actually animal is a class and cat is an object. Let's see, that we discuss. This is logical and this cat is physical. It is a logical entity, this class. Although here it is abstract class, but still it is a class. So it is a logical entity, but cat is a physical entity right here. So I am just saying the sound of the cat. I have created a method for this animal sound. So for that, I am just using this animal sound. Then I am creating an object of type my cat, right? So this is how actually it is working. Can you take abstract keyword before public? Yeah, it can be taken. Nowadays there are so many methods now you can use. You can check it. Let us check it over here as well. If it will go error, then let us check. Yes, it works fine. So we have to check it. Whenever you are getting any kind of a doubt, just run it your way. So it is working fine. Anything else? Okay, fine. Is it clear? Okay, so as we see over here, this abstract and the order of this public and abstract, there it hardly matters. It doesn't matter. So you can use either first public, or you can use like over here. You can use either public here or abstract. So order hardly matters. That we see. Okay. Let me go back to my screen. Presentation screen is where. Okay. So this was it. We checked it. Then there is another concept, we call that as encapsulation. Right? What is encapsulation? It is simply combining. We can encapsulate the things. Or I can say it is kind of a wrapping. Wrapping up of data and methods into a single unit called class. Whenever we are wrapping something here is like data, or it can be a method. Whenever we are wrapping up this data and methods into a single unit, that unit can be class. We call that as encapsulation. For example, in school, a student cannot exist without a class. So we are actually doing what? We are actually wrapping this student within the class, inside the class. So that is encapsulation. Right? Fine. So this is another concept of encapsulation. Okay, then we have got inheritance. Inheritance is another concept, important OOP concept. Right? Inheritance is very much important concept in OOPs. Can you give a definition of inheritance? See, if we see inheritance is simply, I can say like this, kind of a mechanism in which a class acquires the properties of another class. The properties can be methods and it can be fields. So whenever you have got one class and that class is actually acquiring what? Some of the properties of another class. Then from which the class is acquiring these properties, we call that as base class. And the class which is acquiring the properties, we call that as derived class. So it is a fundamental concept of OOPs. And it actually allows the I told it in abstraction as well, code reusability. At that time I told you that actually inheritance is actually allowing this code reusability. And it is also at the same time, this inheritance is creating kind of this hierarchical relationships between the classes. But you might be knowing what hierarchical relationship is. It is simple. Like for example, we are acquiring, or I can say inheriting the traits from our parents. They are inheriting them from their parents. So it is like grandparents, parents, we, our children, their children, etc. So it is a kind of an inheritance. So it is a kind of, I can say, hierarchical relationship. Right? So this inheritance is supporting this concept of hierarchical classification. Like if we see over here, bird, it is a kind of a class. So there are two subclasses, flying bird and non-flying birds. Then in flying birds, we have robin, we have parrot. Similarly, in non-flying birds, we have penguin, we have kiwi. So these are actually, these objects are actually acquiring, inheriting the features from their parent classes. Similarly here, and these two classes are acquiring features from their parent class. We call this kind of relationship as hierarchical relationship, right? And this is inheritance. Then there are types of inheritance. Let us see them further. Yeah, there I have written an example over here. See, this is a parent class, animal, and I have created a method eat. Then animal is eating. Then I have created another class, right? Then I have created a method bark. Dog is barking. Then main class to test inheritance. Now I am just checking whether this class is inheriting the features from the parent class or not. So what I am doing? I am simply checking the inheritance. Then I am creating an object dog is equal to new dog dot eat inherited from the animal class. This function eat method. Then dog dot path method defined in the dog class. This is the method defined in this class itself. Let us check. Again, I am copying it from here. I have already copied the codes so that the time will not be wasted. Otherwise, I have to write it line by line. So most of the time will be spent in writing the code. So better is to utilize time somewhere else and we can copy it. Okay. So this is the compiler. This is inheritance, right? Let us run it. I guess it was not copied completely. Just a minute, it was half copied only. Okay. Yes. See the output. Let us check again. Oh, what happened to it? Cannot find the string method in class animal. What happened to it? Can anyone find the error? Okay, can you find the error? Part wise. This. Okay, let it be. Cannot find a string method in class this. Code is fine, code is not wrong. Okay, let it be. Actually, what we are doing, we are simply code is fine. There is nothing wrong in the code itself. I have checked it multiple times. It is working on other platforms. Okay, let it be. So simply saying that inheritance is actually doing what? It is actually simply, I can say like inheriting the features from the parent class. Okay. Let us go back to the presentation. Yes. See here, it will simply show animal is eating and dog is barking. This could be the output of this program. See here, now we have got multiple types of inheritance. Like you have multi-level inheritance, you have multiple inheritance, you have hierarchical inheritance, single inheritance is also there. So these are some of the types of inheritance. If we see single inheritance, it refers to deriving a class from a single class. So whenever you have a class, like in this example, it was simply a single inheritance. So we are deriving a class from the parent class. We are deriving this class from this class. So it was a single inheritance. If a class is derived from more than one base class, it is known as multiple inheritance. Like over here. See, this class C, it is being inherited from multiple base classes. As I already told you, we have two classes, base class and derived class. Base class is simply a class, or I can say a parent class, from which the derived class is inheriting the features, inheriting the characters. And this derived class is the class which is actually inheriting the features from the base class. So whenever your derived class is having multiple base classes, or you can say whenever a derived class is deriving the features from multiple base classes, or I can say more than one base classes, we can say it is multiple inheritance. Right? Then we have got this multiple or multi-level inheritance. This is multi-level inheritance. When you have got one base class, then derived class, and that derived class acts as a base class for another derived class, and so on. So whenever you have got this kind of inheritance, you can say it is multi-level inheritance. Right? Then you have got this, and one more is hybrid inheritance. Hybrid inheritance is simply whenever your inheritance, this hierarchical relationship, it is containing different types of inheritance. Yeah, then there is another concept we call that as polymorphism. What is polymorphism? Can anyone tell me what is polymorphism? Yes. Yeah, poly means many, morphism means forms, right? Good. Adding of two numbers, three numbers, taking different arguments, right? So polymorphism is simply what? If we say it is a Greek term, poly means many and morph means form. So actually it is the ability to take more than one form. Or I can say when a task is completed in more than one maze, right? Yeah, an operation may exhibit different behaviors in different instances. So at that time also it is polymorphism, because same operation, same operator is behaving differently, and this behavior depends upon the type of data used in the operation, and whatever data you have got, this behavior depends upon that type. So this polymorphism actually it enables in Java, it enables objects of different classes to be treated as objects of a common type. Means whenever you have got different classes, and these classes are to be treated as objects of a common type, right? And the benefits of polymorphism, or I can say the features of polymorphism, like in inheritance, the code reusability. We can write a generic code that works with objects of different classes. It is flexible. There is flexibility with the help of this polymorphism. We can easily extend and modify code without affecting the existing functionality. Right? Then abstraction, we can hide complex implementation details and expose only the essential information that we did in data abstraction that can be implemented with the help of this polymorphism, right? And then there are two types of polymorphism. One is compile time polymorphism, or we call it as method overloading or static. Then another one is runtime polymorphism. We call it as method overriding or dynamic. Now, what is method overloading? See, we can have multiple methods. If you have multiple methods with the same name but with different signature, for example, you can have number, type, and order of parameters. We call that as method overloading. Once you are done with these concepts, now we can implement them in example. Then we go a bit further. Similarly, you have got method overriding. When a subclass, the class that we created from the base class or a derived class, contain a method with the same name and signature as in the superclass. Means whatever is the superclass, like suppose animals, and you have created a subclass, for example, running animal. When this subclass is containing a method with the same name as we have created a method in the superclass, like in animals, we call that as method overriding. Then there is another concept in OOPS, or I can say in Java, we call that as dynamic binding. So see, binding simply refers the linking of a procedure call to the code to be executed in response to the call. Means it simply refers the linking. Whenever you are linking something, you are linking procedures, functions, methods. So whenever we are this is not linking procedures. So this binding actually refers to the linking of a procedure call to the code to be executed in response to the call. So whenever we are linking this procedure call with the code which is to be executed in response to the call, means you have created a procedure call and there is a code. Whenever you are linking this procedure call to the code, and it is to be executed in response to the procedure call that you have created. So at that time we can say it is binding. Simple. Linking of you have a procedure call, you have a code. So whenever you are linking this procedure call to this code, and it is to be executed, code to be executed in response to the procedure call that you have created. And this dynamic binding simply means the code associated with a given procedure call is not known until the time of. It is simple. Whenever you are binding it, this procedure call with the code to be executed in response to this procedure call. So it is actually not known until the time of call at the runtime. Whenever you are calling that procedure call, whenever this code is getting executed actually, because at the time of execution, the code is being executed in response to the call. So at that time, it is getting called. It is associated with polymorphism and inheritance, this dynamic binding. Then we have another concept, we call that as message passing. See, these are some of the concepts in OOPS. We have to know these concepts. Now, what is message passing? Simple. A message for an object is a request for execution of a procedure. You have a procedure, you want to execute that procedure. So this message is simply a kind of a message, I can say, for any object. Or I can say a message is a kind of a request. Whenever you have to execute a procedure. So we are just passing a message. Or I can say we are just passing a request for an object to execute this procedure. Or I can say, see, it is a kind of a request, or I can say simply a message passing for an object to execute a procedure. And at the same time, it is a process of invoking an operation of an object on an object. Means you have to perform an operation on an object, or I can say you have to execute a procedure. So what are you actually doing? You are actually invoking something. So this process of invoking an operation on that object is simply a message passing. Means you have an object, you want to perform an operation on that object, right? So you have to perform something. So whatever what you are doing, we are just invoking something. Means we are invoking an operation onto that object. And whenever we are invoking an operation onto an object, this is a kind of a process, and this process is called as message passing. And it simply involves the name of an object on which we are invoking the operation, and the method, or I can say the message, and the information to be sent. For example, if we see employee.salary and name, here employee is the object, salary is the message, right? And name is the parameter that contains the information. So we are actually doing what? We are actually invoking an operation on this employee object. What operation? Salary name. Means we are actually passing this message salary. We are actually invoking this operation onto this object. So this is what is message passing. Now this is a summary of today's lecture until now. Simply, initially what we discussed, objects and instance of the class, abstraction, then what abstraction is doing, code reusability, then abstraction enables program open for execution, then encapsulation, inheritance, polymorphism, and this is the conclusion of today's session. If you have any questions, you can ask. Then we'll go for a 10-minute break. Yes. If you have any questions till now, then we will go for a break. Okay, let us go for a break for, I can say, till 8:10. See, I have already repeated these OOPS concepts. Yeah. What is? Oh, dynamic binding. Okay, let me explain dynamic binding one more time. See, dynamic binding, as I already told you, it simply refers to the linking of a procedure call to the code to be executed. For example, I can tell you like this. It is also called as late binding. For example, you have got a method which is to be called. If that method, it is a kind of a process. where the method which is to be called is resolved during runtime, right? So we call that as dynamic binding. It is also called as late binding. See here also. For example, see, binding refer, again I am saying binding refers to the linking of a procedure call to the code to be executed in response to the call. For example, you have a code which is to be executed, and you just want to link procedure call to this code which is to be executed. And whenever we are executing this code, and this code is actually doing what? It is invoking kind of a call, and that is called as binding. Simply linking of procedure call to the code which is to be executed in response to the call. And it also means that code associated with a given procedure call is not known until the time of run. And we have this binding of two types, static versus dynamic. And if you remember the static binding, it is simply which can be resolved at compile time by the compiler. The binding which is resolved by the by compiler at the runtime itself. So we call that as static binding. But in dynamic binding, this compiler does not decide the method to be called. You see this now, you might have heard about this overriding. That is the perfect example of dynamic binding. And both this in overriding, I guess both parent as well as the child, they have the same method, right? Okay. Okay, let us go for the break for, I can say, polymorphism. Again, I told you poly means many and morphs means forms. So if we have got multiple forms of this, multiple forms, we call that as polymorphism. Means ability to take more than one form. Or I can say if a task is performed in by different ways. So we call that as polymorphism. And we have got two types of polymorphism, compile time and runtime. Okay, na? Let us go for the break. We will be back at, can say like, check the time. Break is till 8:15. Okay, yes. Or I can say 20:15. Okay, let us go for the break. After that, we'll see the data structure array. Okay. Okay, good evening. Okay, let us start. We will be now discussing about arrays. Let me share the screen. Hope I am audible. Okay, screen is also visible to you. Okay, fine. See, if you remember the data structures that we discussed, I guess on day 1. So we have discussed about so many data structures like primitive, non-primitive. Right? Then we discussed about linear and non-linear data structures. And one of the linear data structure is arrays. So in today's session, we'll be discussing arrays and some operations of arrays. Right? Can anyone tell me what is an array? Quickly. What is an array? Yes. Be quick with your answers. Yeah, actually an array is a data structure, or to be more precise, it is a linear data structure which is containing homogeneous data items, or I can say a similar collection of data elements. Yes, you are giving the definition is collection of homogeneous data items. Array is a collection of similar type of, yes. So array is simply a data structure or a linear data structure which is containing homogeneous data items. Right? See, in this slide, what we will be doing, arrays in Java, advantages, disadvantages, what are the different types of arrays, how do we declare an array, how do we create an array, how do we process arrays, etc. etc. So these are some of the topics that we will be discussing in today's session. Okay, see, array is used to store a collection of variables of same type, means a collection of homogeneous data items. By declaring an array, a memory space is allocated for some values, for values of a particular type. See, do you know what happens actually when we declare any variable, be it array, be it int, be it any other data type? What actually happens? For example, if I am writing like this, when I am writing like int, like suppose ARR, yeah, let me suppose int a comma b comma c. What actually is happening? What this statement is conveying to the compiler? Can anyone? What is this statement telling to the compiler? Declaration of variable, very nice. It is declaration of variable, but what it is, what it is conveying to the compiler? See, I will tell you. It is simply saying the compiler that I am using 3 variables, and the type of those variables is int. When this statement we are writing, and after that the compiler gets to know that the user is using these three variables and it is declaring that the type of these variables is int. So it is actually allocating the memory locations, right, for these variables. And later it will check how many bytes of each variable will take. So it is actually doing what? It is actually creating memory locations for these three variables. And what could be the size if it is like int? So I can assume like it is 2 bytes for A, 2 bytes for B, and 2 bytes for C. So this compiler, this program is telling the compiler that you have to allocate 6 bytes of memory for these three variables. Means here it will go A, it will go B, and it will go C. So this is actually happening inside the computer whenever we are declaring this kind of a statement. It can be array, it can be any other data structure or any other data type. So like this, we are actually doing this declaration. And with the help of this declaration, actually this thing happens in the computer. And compiler is doing like this. We are telling the compiler that we are declaring these things and you have to do this. So in memory, we are this program is till now getting 6 bytes of memory. Hope it is clear. Yes. Fine. Okay. See. And you know, these arrays in Java, they are index based. Right? Means someone also asked this question, why array index, or I can say this index starts from 0. If you remember, I have told you, it is actually this base address, or I can say at that time I have told you about the offset. Right? Now what is offset? Offset is simply whenever you are declaring an array, like suppose this, and it is index starts from 0, means this memory location is having some address. For example, it can be having address 100 or something like that. Right? So if you have to refer to this memory location, so at that time what you will be doing? You will be making use of index. And the index is 0, means you don't have to perform any calculation. Simply it will refer to this location. If the index would have been 1, 2, or 3, then you have to unnecessarily subtract that value. So that is why index starts from 0 and it acts as an offset. Means we are simply referencing to the base memory address. Right? So that is why we are just saying in arrays in this Java, the array index, or I can say the index starts from 0. And the index must be a non-negative number. It is obvious it cannot be a negative number, because whenever you are referencing to a memory location, so it has to be either 0 or greater than 0. It cannot be negative. Okay, then we have got some advantages of arrays. I will tell you how to declare array, how to process array. We have to perform those operations here. Now the very basic advantage of arrays is code optimization. Means it makes the code optimized. We can retrieve or sort the data with the help of arrays. This retrieving or sorting, it is easy. And we can have the random access, means we can get any data located at any index position easily. Simply you have to do what? You have to subtract the index if you want to point any array index or any memory location. Simply you can get to that location. And now there are some disadvantages to the arrays. The very disadvantage is size limit. You can store only the fixed size of elements in the array. Means whenever whatever size you have got, because initially you are declaring the size of an array. If somehow or in between, or the size of the elements, or I can say the number of elements is more, so at that time it is a drawback. So if you have got a fixed size of elements, you can store only those. It does not grow in its size at runtime. Means whatever size you are giving initially, it will adjust only those number of elements. If the size is, or I can say the number of elements is more, so it does not adjust those elements. So at runtime, it is not growing its size. Yeah, now there are some types of arrays. There are mainly two types of arrays, single dimensional array and multi-dimensional array. You might be knowing it well. 1D array in a linear manner, right? It has got only a single row of elements. And 2D array means multi-dimensional array can be 2D array, 3D array or multi-dimensional array. 2D array is simply a matrix, isn't it? It is a matrix here. This is the linear array. And these are the array indices. Right? The first index is 0 and the last index is 8. And this is the length of the array 0 to 8 means we have got 9 elements. So this is single dimensional array. It is a single row. Now, just a minute. Thing is getting hanged. Then we have got 2D array. 2D arrays are also important. Whenever we are dealing with the data structure Java or this C++, or whenever we are handling different kinds of problems, whether it is a graph, prowling salesman person problem, or whenever you are dealing with shortest job first, or this shortest path algorithms, at that time, these 2D arrays are important. Because whenever you have any kind of the shortest path or traveling salesman person problem, so at that time we are actually representing those graphs, or I can say sometimes trees, we are representing them with the help of matrices, 2D arrays we call them, in the form of rows and columns. Right? You might be, can anyone give me the example? Actually, it is that this now we call that as representation, memory representation of arrays as well. Can anyone give me a practical example where you are using graph, these 2D arrays? Yes. Any practical example? Databases, student marks, RAM and ROM, Sudoku problem. Okay, in this now, with the help of graph I am just saying. Mark sheet, it is a 2D example, good matrix. Practical example where you are implementing any problem with the help of this 2D array. Image formation, pixels. Yes, traveling salesman problem. We'll be discussing traveling salesman problem in coming lecture with the help of dynamic programming. Okay, if you know 8 queen problem is also there. Knapsack can be represented with the help of this. Sorting algorithms. Sorting is simply linear. Chessboard. Yes. So shortest path algorithm, seating arrangement. See, there are so many examples. Great. If I will tell you a practical example, you might be knowing about Google Maps. So whenever you are using Google Maps, what you are using? It is an example of a tree. So whenever we are representing this, now we are representing these like Google Map from ST-A to ST-B to ST-D to ST. So we are actually representing it with the help of matrix, with the help of, for example, if I have got four STs, 1, 2, 3, 4, ST1 to ST1 itself, ST1 to 2, ST1 to 3, ST1 to 4, right? So actually here we are doing what? We are actually calculating the cost. For example, if I will be, whether I am able to draw the table or not here. For example, if it is cost is 0, 1 to 1. Similarly, it is 2, it is 3, it can be so on. So it is actually cost between every city. So at the end, I will be calculating the shortest path among each pair of cities. So with the help of these arrays. So here I am just saying that we can represent this data in the form of array. That is why I am just saying what is 2D array. Unless and until you know the application part, then it is difficult. It is difficult to like tell you why we need arrays. So arrays are important because we have so many data structures, or I can say so many applications where you can represent their data in the form of 2D arrays. Okay. Now we have 1D array. As we already discussed, 1D array is this in a single row where single array holds multiple values of same type. We have got index, we have got fixed index, first index, and then we have got last index. Then based on that, we can calculate the total size of array. Now, how do we declare 1D array in Java? See, declaration is simply what? Telling the compiler what I am using. Means you must declare a variable to reference the array. You have to create a variable. In order to reference that array, if you have a data in the form of array, you want to reference that array. So with the help of variable, you can reference that array. And this is the simple syntax to declare an array. Data type, this brackets, then array, or data type, then brackets, then this. But this is the preferred way. Data type, brackets, then array, and this is not the preferred way. So, but you can use either of the way. Both of the ways are correct. Both of the ways can be used to declare an array, but this first one is the preferred way. We'll be doing the example. Okay. Now, how do we create array? See, we can create an array by using the new operator, and this is the syntax. For example, this is the declaration of an array, right? And with the help of new, you can create a new array. So with the help of new it is a kind of an operator, this new. This new is actually an operator. So with the help of this operator, what we are doing, we are actually creating an array. And this is the data type of that new array, and this is the size of the array that we are going to create. Or alternatively, we can create array like this as well. Simply data type, and we will pass the values that you want to put in that one-dimensional array. For example, if we see, I have examples that we'll see later. So first you have to remember the syntax in Java. Simply data type array. If you want to create a new array, just write new data type array size, or simply like in C, we are simply creating arrays like this, data type array, then the values which you are going to pass. For example, I have created an array like this. A, data type is double. So it will be declaring an array A. Then I am creating a new array, new double of size n. Then I am entering these values. For I is equal to 0, I less than or equal to n, I plus plus. So I am just writing n 0 to n minus 1 values into that array, right? So I will be initializing all those elements to 0. Means there will be an array of all elements equal to 0. So this is how do we create and how do we declare an array. Right? Then after that, we have got the processing of an array. Let me check here first. Let me take this example. I have already an example over here. let me share the screen again. Okay, this is the online compiler. See here, I have created an array of numbers with the name. Again, it is not okay. I am not running it. I thought it is showing the same error. Okay, see here, I have created an array of elements. For example, this array example. Then I am creating this array of numbers and new int 5. Simple. I am creating an array with this variable new, or I can say this method, right? So this actually, this new is an operator. So with the help of this new operator, we are creating an array, right? Then I am initializing the array elements. For example, I am just passing 5 elements to it. You can check the index. So int numbers, I am using this new operator and I am creating an array of 5 numbers. And again, I am initializing those 5 numbers like this, or you can simply, like, if you know, you can simply write this way as well. Int any array ARR if I am naming, and I can pass initialize the values like 1, 2, 3, 4, 5, etc., etc. So whatever numbers you are entering over here, you can pass those numbers into that array, or you can pass the numbers like this. So it is equally likely. You can pass the numbers like this, or you can initialize the array elements like this. So this is how do we initialize. This is how do we create an array with the help of new operator, and with we are initializing the arrays like this. Then how do we access? Let us go back to this slide. Hope it is clear. Yes, is it fine? Okay, then after that, what we will be doing? We will be processing the arrays. See, arrays can be processed with the help of loops, right? You might be knowing it well. When processing array elements, we often use either for loop or for each loop. We have got two loops, for loop or for each loop, because all of the elements in the array are of same type and same size of the array. Whenever we have got an array, if you want to process the elements of an array, right? So you can use either of the loop, either the for loop or for each loop. I will show you how we are using these loops. And one more thing about arrays, we all know that because all the elements are of same type, and also the size of the array is already known, because whenever we are declaring the array, we usually, most of the times, we pass the size over there, right? So here's an example. How do we create, initialize, and showing the? Let me take that example again, which we were discussing. Hope the screen is visible. This online compiler screen. Okay, see here now. This thing we discuss. This thing we discuss. And this is how do we initialize the array. This is another way. Right? And this is another way of initializing. Now, how do we access the elements? See here. Let me put the comments. I have used what? For loop. If we check over here. For I is equal to 0, I less than or equal to numbers dot length. What does this numbers dot length mean? Can anyone tell me? What does this numbers dot length mean? Yes. What does this mean? Yeah. Okay, length of array, index, size, fine. So it is simply used to determine the size of an array. See, and one more thing about this numbers dot length is it is a property. It is not a method. And it will simply, if you see now, if we run this numbers dot length, it will simply return the number of elements in the array. And that number would be obviously an integer. And this numbers dot length is applicable to arrays only. Right? And if you know the other method is they are using like dot size, like this. For example, they are using like dot size, or they are using dot length as well, but like this. At that time, it is a method. So it is used by these strings, string dot length, string dot size. But this string dot length, it is simply a what? Property. It is not a method over here. Remember it. Right? So here I am just simply trying to find the number of elements in an array. And obviously then I am doing what? I am just using the for loop to check the total number of elements in the array, and then I am printing those numbers. If we check element at index I, so it will be first element 10, then simply 20, then 30, and so on. So this is actually what? The array elements in the array. What is the element at index? So this is how we actually create the array, process the array, and access the elements of an array. Okay? So this is how do we do all these things. Is it fine? Is it okay? Done? Do confirm. Okay, great. If we see another program to process the arrays in the same compiler, let me run it. See here, I have used two for loops. One is simply for loop and another one is for each loop. As I already told you that in the last slide, I guess. If you remember, I told you that we can use either for loop or for each loop for accessing or processing the array element. So this is the example for that. See, I have created an array of numbers and I have initialized it like the way that I previously shown in the previous example. If we see, I have initialized these objects to this array. Then I am just using for loop. For I is equal to 0, same way in the previous example that I used. For I less than or equal less than numbers dot length. Then simply system dot print element is that. So here, check here. It is enhanced for loop. For int numbers colon numbers. What is this int colon numbers doing actually? Yes, what it is doing? Can anyone? Yes. Int represents the value integer given. Storing numbers to a number variable and printing it in. See, I will explain. Yes, you are giving right answers as well. If you see this int simply, it is representing the variable, right? That is holding the current number. During each iteration, of the loop. So this int will hold the current number that it is doing for every loop. For example, int I is equal to this, and this. So this int will simply do what? It will indicate that the variable it is holding is the current number during the iteration. Then the first number. This is the variable name. And this variable name will be assigned the value of the current number in the iteration. Means this number will be assigned the what? Will be assigned the value of the current number in the iteration. Means whatever is the current. For example, if I is equal to 0, so initially it will be assigned 0. Second time, if I is equal to 1, 2, so it will be assigned the current number in the iteration. And what about the third number? This specifies that the loop will iterate over the elements of the collection. Means whatever would be the elements of the collection, this will iterate to over those elements. For example, in our case, it is an array. So this will iterate to those numbers. It is equally likely like this. So then it will simply print element and the number. Element is 10, number is whatever would be, element is simply element, and this number would be whatever would be the number present in the array. So this is simply for each loop. And this was whatever we are, the conventional way. So here it is simply the other way that we are, how we are using this for each loop. Right? Yes. Okay. So this is how do we process the array. Let me go back to the presentation slide. Okay. Yeah, then we have this for and for each loop that we did. Int numbers, for int number to my list. There we write int number to numbers. It is writing int element to my list. So here I've got my list over here. So it is simply for each loop. So it will traverse the complete array sequentially without using an index. Here it is not using any kind of an index variable for each. So it will simply do what? It will simply traverse the complete array sequentially one by one with the help of this element. or I can say this index variable, but to be more precise, there is no index variable over here. So it is simply traversing the whole list. Yeah, then there is jump and other statements. So if you have got any questions, please ask. Tomorrow we will see the operations on array. And I guess it is now difficult to cover the operations. If you see, we have got multiple operations in arrays. We have got so, if you have any questions, you can ask. Can you tell me what are the different operations on an array? That we'll be discussing tomorrow. Yeah, there are so many operations in an array. If you see, the very basic operation starts from accessing the array elements. That we did. Simply use the loop, for loop or for each loop. You can traverse each and every element. Then you can iterate over the array with the help of for loop again. Then if you want to find the length of an array, simply dot length. Then the very important operation, that is the sort. How do we sort arrays? How do we sort the elements in an array? Then another operation is how do we search an element in an array? Right? There are then we have got binary search, we have got linear search in a list, if we say. So that we'll be discussing. So searching is another operation in an array. Right? So we'll be doing. Can anyone explain me? Let me tell you a bit about this. I guess linear search we discussed. I guess we discussed linear search, isn't it? Blank sheet. Okay, let me get a blank sheet over here. Let us discuss the binary search complexity in these 5-10 minutes. I guess 5 minutes. What is the complexity of binary search? Yes. What is the complexity of binary search? Can anyone? Order of login. Good. How it is login? Can anyone define me? That is order of login. Great. See, I have got a list. There is one, I can say not limitation. There is a precondition for a binary search. Can anyone tell me what is that condition for a binary search? In order to perform a binary search, there is a basic condition. Yes. All the elements should be sorted. The array or the list should be already sorted. Only then you can perform the binary search. For example, let me tell you, if I have an array or a list of elements like this. I will tell you what is the binary search, how it is working. So this is an array, or I can say a list. Now, in order to perform a binary search, the very basic condition is that the list should be sorted. Yes, it is sorted, right? Because the elements are in order. See, the binary search is solved, or I can say we apply the divide and conquer strategy for binary search. We call that a DNC, divide and conquer. What divide and conquer is doing, it is actually dividing this list into two sub lists, or we can say that divide the problem into two sub problems. So here what I am doing, we are actually finding the mid over here. How do we find the mid? It is low plus high divided by 2, isn't it? So what is the low? If I will say 0, and what is high? It is 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it is 0 plus 11. So it is 11 divided by 2, it is 5.5. So actually what we are doing, we are, you might be knowing about the seal value and the floor value. I will be discussing them. Seal value and floor value. So we will be taking, like suppose either seal or floor. Most of the times we take the seal value. So it is 6, right? So on the base of this, I am dividing the list. 6. 6 is the mid. 1, 0, 1, 2, 3, 4. No, it is actually, yes, it is low plus high divided by 2 plus 1. Whatever it would be. So I will be going to the 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so it would be the middle element. Whatever. Then, like suppose this 16 or any element, I will consider this as mid. Let it be. Right? This is the mid. Now the element which I have to search is like suppose this 98. Let us put it otherwise. What would be the best case in binary search? Can anyone? What is the best case in binary search? Quickly. Element at 0 position, no. 18 is mid. Yes, 18 is mid. I'm just, that's why I told you now, I put it otherwise. That is why I did it like this. So the best case in binary search is either when the element is, yes, is at the mid position, right? For example, if you have to find the 18 element, so I am just comparing my 18 with the mid. So it is the best case. So in binary search, the best case is when it is the first element. First means which is going to be compared first. So here I am first comparing the mid element. So that is the best case. And now what is the worst case in binary search? Yes, what is the worst case in binary search? What is the worst case in binary search? If the element is not present at all, right? So you are just saying the complexity. I'm not asking about complexity. When is, I am just saying, when is the worst case? Yes, it is when the element is either at the first position or at the last position. And I will show you how. So the best case is when the element is at the mid, and the worst case is when the element is at the first or at the last position. Let me show you. For example, I am just comparing mid. If it is mid, the element is found and that is it. Then the complexity is order of 1. So it is the best case. Whenever we are searching, whatever we are searching, it is, we are finding it in the very first go. Now, what if the element is here or what if the element is here? See, I am just trying to find 99. Now I'll compare my 99 with this mid element. So what I will do? I will check if it is greater than mid, I will traverse only the second part of the array. If this 99 is less than this 18, I will traverse only the first part of the array. So here 99 is greater than this, so I will be traversing this part of array. For this part, again using divide and conquer, I will be finding again a mid. So in this array, like suppose the mid is 78. Again, I am comparing 78 with what? With my element 99. So here it is greater than. So this part will be excluded and I will traverse only this part. Again, 99 will be compared with the mid. So there are only two elements. So it would be 99 itself. So it is found at the last. If we make use of a tree, see at every step of the tree, if there were 10 elements, like suppose 10. During the first comparison, the array got divided into 5 and 5, isn't it? During first comparison, what happened? This 5 got excluded, means I am just only comparing 5 elements. This in the second step, it is further getting divided into, like suppose 2 and 2 or 3 and 3, whatever would be the case. And again, this part gets excluded. I am not using my effort, using my processing time in comparing these elements. Here also, I am doing like this. So it is at every step of the tree, it is dividing the elements by 2. At every step of the tree, it is dividing the elements by 2. So whenever this is the case, means at every step, you are dividing the elements by 2, or you are, I can say, this na, you are dividing the process by its half. The complexity usually remains the logarithmic. Means if you have 16 elements, you can reach to the leaf node in how many steps? In how many levels? In 4 levels only. So that is why the complexity of binary search is log n. Because if you have 16 elements in an array, what is the complexity of worst case complexity of that array? It is simply log of 16 to the base 4. So that is 4, means you will reach to the leaf node in that array in 4 steps only. So that is why we are just saying the complexity of binary search is log n. Hope it is clear. Yes or no? Is it fine? You can give a thumbs up if you understood the concept of this binary search complexity. Okay, great. So I guess we'll wind up the session here today. Tomorrow we'll continue with the arrays, and we can take another data structure tomorrow. Okay.
Yeah, okay, sir. We'll find
Thank you so much.
Yeah.
Good night.
We'll meet again by tomorrow.